All right, I wanted to make one more video showing one more type of circuit. So we talked about series, just a summary. Here are the equations that went away with series. So we said that the voltage of the battery equaled the voltage of each voltage drop across each different resistor. The current throughout the whole circuit is the same. The current that runs through resistor 1 is equal to the current that runs through resistor 2 is equal to the current running out of and into the battery. Then R total is just simply the sum of all the individual resistors' resistance. Parallel is a little bit different. Parallel is when you got those branches, and so the voltage drop across each resistor should actually be equal to each other. That's going to be equal to the voltage of the battery. I total is not equal to each other like the series. Instead, I total is just simply I1 plus I2, so on and so forth. And then down here, the total resistance is actually a reciprocal relationship. And so here's the new kind of circuit, which is more realistic as to what we actually use in most circuits. It's called a combination circuit, as you'll find out pretty quickly. So start with my finger here at the battery. I come out of the battery to the positive end, and I come here, and I run through one resistor. So this looks like it's going to be a series circuit. But then I get to a point where it branches off. And so I follow this branch. Now it looks like it's a parallel, but then I run across two resistors along that parallel branch. Those guys are in series. So right now what I've got is something in series with the battery, resistors that are parallel to each other, and then also resistors in the parallel branch that are in series with each other. So the question that we're going to work out is exactly the same thing. We're going to try and solve for the following. V1, I1, R1, V2, I2, R2, V3, I3, R3, and then V4, I4, and R4. And of course we're going to have the VBAT, I total, and then we're going to have the R total. So let's fill in the blanks that we already know from this problem. So according to this, the voltage of the battery is 9 volts. The resistance of resistor 1 is 2 ohms. The resistance of resistor 2 is 3 ohms. Resistance 3 is 4 ohms. And then resistance 4 is 8 ohms. And we have a whole bunch of unknowns. So series and parallel circuits work as following. Here's what I always like to do. I like to break this guy down into several different circuits. So let me get this guy out of here. I'm going to move this guy over here. And what I'm going to focus on is this. I'm just going to draw a series of new circuits where I'm going to try and focus on the series and parallel branch. And so I'm going to look at things that I can possibly combine together to make this circuit into one series branch. That's my goal, to try and get this drawing submitted down or reduced down to one series branch. And so therefore I'm going to look at this parallel branch here and I'm going to try and simplify it. Well, right now I've got these guys in series like such. So what I'm going to do is I'm just going to come over here and I'm going to draw a new picture where I've reduced these guys down to one resistor. And so what I'm going to do is I'm going to come over here, I'm going to redraw my battery. My picture won't be as good this time, sorry. There's my resistor 1. Then I'm going to branch it. Here's resistor 4 right there. This is R4. And then over here, I'm just going to draw one resistor. And the reason I'm going to do that is because if you're thinking, wait a minute, but there's two different resistors here. Well, I'm going to call this not resistor 2 or resistor 3. I'm going to call this resistor 2, 3. And I actually know what the resistance of that is. Well, I know that because these guys are in series to each other. And if I want to find the total resistance across this branch, if you remember, because they're in series, R total is equal to R1 plus R2. So if I wanted to find the total resistance across this branch, all I got to do is take 3 plus 4, and that is 7 ohms. So I put 7 ohms there. I'm just going to finish writing the values over here. So I got 2 ohms. This is a 9 volt battery. And then R4 is 8 ohms. And then I need to connect this guy back to the terminal. Okay, so very good job. Now we've reduced it down to a series resistor and a parallel resistor. So now what I want to do is I want to resist that parallel branch down to one series. And so I can do that by saying, okay, well, just like here I wanted to resist that to one resistor, I want to figure out what the total resistance is across that branch right there. And so then I'm going to come up and I'm going to draw another diagram right here. And in this case here, I'm not even going to show a parallel branch, this being 9 volts, this being R1 of 2 ohms, and this guy is no longer R2 or R3 or R4. It's a combination of all of them because it's a total resistance of R2, 3, and 4. So you're like, well, how do you calculate the total resistance? Well, right now I've got 2 resistors that are in parallel to each other. How do I figure out the resistance? I use the inverse. So I've got to grab a calculator real quick. So what I need to do is I need to take 1 divided by 7 plus 1 divided by 8, and then find the inverse of that. That is, the resistance of R2, 3, and 4 combined is 3.73 ohms. Just like that. Now I've got it as one series circuit, which is huge because now when I come over here and I'm like, well, I want to figure out my total resistance. Total resistance across the series branch is easy. All I got to do is add the total resistance. And so I just simply add those guys together, 2 plus 3.73. That is equal to, let me get my red out, that's equal to 5.73 ohms. Okay, now we're cooking. Because we've got 2 of these guys, which means we can use Ohm's law, B is equal to IR. Again, circuit chemistry, one of the biggest used equations. Therefore, I can plug those numbers in to find I total. So all I need to do is take 9 divided by 5.73, and that will tell me the current that is coming out of the battery and going into the battery. That's 1.57 amps. So therefore, on my picture, I'm just going to draw that 1.57 amps, and that's going to continue going till we get here, and then that 1.57 amps is going to continue down here as well. So going into the node and then coming out of the node. Now, this is not the same current because it's splitting off. But I do know that that is 1.57 amps. Well, look at this. That 1.57 amps is running through one of our resistors. That's R1. So look, that is in series, which means that is the same current, 1.57 amps for resistor 1. So now how do I find the voltage drop across that? Well, I've got 1.57 times 2, and that's equal to pi, or 3.14 volts. Okay, now we're starting to cook a little bit. So with this, I'm also going to write the voltage drop across here. I know that the voltage drop across this resistor is 3.14 volts. Okay, so now comes the part where people are like, I don't know where to go from here. Well, if you think about it this way, come over here to this circuit right here. If I know that this guy has a voltage drop of 3.14 volts, the total voltage of the battery is 9 volts, then what's the leftover voltage that has to be coming out of resistor 234? Well, that's in series, right? To find the leftover resistance, the series voltage drop is simply V bat is equal to V1 plus V2, so on and so forth. So therefore, if I want to find out what the resistance across resistor 234 is, then I would take 9 minus 3.14, and you're going to get 5.86 volts. Okay, so what does that mean? Well, when I come up here to parallel, like this, across resistor 1, I'm dealing with a voltage drop of 3.14 volts. Then, when I come to this node, if I come this way, then the voltage drop has to be 5.86 volts. If I come this way, what's it got to be? Well, it's also got to be 5.86 volts. So the voltage drop across for both of these branches total is going to be 5.86 volts. Well, that's huge because that's telling us the voltage drop across resistor 4. So therefore, I can come over here. Voltage drop across resistor 4 should be 5.86 volts. If that doesn't make sense to you, look at the big grand scheme of things. If I said that this one is 5.86 volts, let's say I'm an electron or a charge, and I'm moving through resistor 1, I've dropped 3.14 volts, then I come to this node, then decide to go this way, 3.14 volts, I'm now dropping another 5.86 volts, that's total of dropping 9 volts. When I come back here, I come to the battery pumps it back up. So that is correct. So now I've got two variables down here on resistor 4. I can figure out the current going into resistor 4. So that's 5.86 divided by 8. The current is 0.73, and we'll go 3. 0.733 amps. Okay, now we're cooking. Now we're really cooking because according to my diagram, I've got 1.57 amps coming in, then going in the branch of R4, we have 0.733 amps. Well, this is parallel, which means that this current equals that current. And so therefore, all I need to do is this current plus this current equals the current going in, which is 1.57. So therefore, all I need to do is take 1.57 minus 0.733, and you get 0.837 amps. So what that means is that's the branch going all the way through this branch right here, which means it's going through resistor 2 and through resistor 3. Oh man, we're in the home stretch. 0.837 amps, 0.837 amps. So now how do I find the voltage drop? Well, I take 0.837 times 3 to figure out the voltage drop across resistor 2. That should be equal to 2.51 volts. Voltage drop across resistor 2 should be 0.837 times 4, and that is 3.35 volts. Now, if you're like, wait a minute, this can't be right. Well, take these two guys added together, 2.51 plus 3.35. You get 5.86, which is what we said that the voltage drop across both of these resistors had to be, the sum of that branch. Therefore, you know you are correct.